All right, so I'm going to go through and do a couple sample problems from chapter 27, and hopefully they'll make sense and they go along with some of the ones that I'm going to ask you to do. So this one's problem 38. It says that a hollow metal sphere has an inner radius of A and an outer radius of B. And it's asking you to follow, gotta maybe make that a little bit bigger. The hollow sphere has a charge of plus 2q. A point charge of plus q sits at the center of the hollow sphere. A, determine the electric fields in the regions where R is less than A, R is between A and B, and R is greater than B, basically. All right, so I don't think I'm going to need a calculator for this, but I've got it ready just in case, so I'll set that up there. First thing I'm going to do is always draw a picture. So for part A, I've got a hollow sphere. It's not bad for me. And that's bad for me. I'm going to call this radius. So here I'm going to have a positive charge. I'm going to call this A. I'm going to call that B. Okay. Now, this sphere here says it's hollow because all this region in here is hollow. But this has a charge as well. So the question then is, what kind of charge do you have at different places? Well, if I think about a Gaussian surface, anywhere in this region, so this is where R is less than A, the net charge enclosed is plus Q. So since electric flux field strength multiplied by the area, the surface interval of those two, and that's equal to Q inside or enclosed divided by vacuum permittivity. Really what we've got here, anytime for where R is less than or equal to this inner radius, we're going to have something like this, where basically what we've got now, that's plus Q over E sub 0. It's asking about the electric field strength, though. So in this case, what I'm going to do is I'm going to take this part of it. I'm going to say E equals Q enclosed over area times E sub 0. Well, the area is 4 pi r squared. So basically it's plus Q over 4 pi r squared E0 equals essentially 1 over Now, if you remember something like this, and that's positive, if you remember something like this, where this 1 over 4 pi epsilon sub 0 is the same thing as k, we could say that's equals to plus k q over r squared. Well, that's the same thing as the electric field formula from a point source, which kind of makes sense. Between A and B, we've got to think about what's happening here. So although the sphere here has got a charge of plus 2q, anytime you're inside a conductor, you're going to have 0 electric field. So what that tells me is I'm going to have a negative charges on the inside of this, and a lot of positive charges on the outside, and that's really getting to part 2. So now, if I do this, I'll make this red. I go back here, say I'm anywhere in this region. Now, if this was positive Q here, I've got negative Q on the inside surface, and that means anywhere in this region between the inside and outside of the hollow conducting sphere, I have no net charge enclosed, so I've got no net field. So what that's going to tell me is the electric field is equal to 0. It also tells me that the electric flux is equal to 0 also, since there's no net charge enclosed. I'll put that right here. All right, so now if I go and think about this again, when, make this purple, R is greater than B, now that is my Gaussian surface, which is just an imaginary surface. And what I can say is I've got plus Q enclosed here, and this hollow sphere has a net charge of plus 2Q. So now net charge enclosed is plus 3Q. So you could determine the electric flux and say basically what we've got now is plus 3Q over epsilon sub 0, and we can go and derive that, and we could say that now the electric field is going to equal that, and that simplifies to that. So again, it really only depends on the amount of charge that's enclosed. For part B here, what it's asking is how much charge is on the inside surface of the hollow sphere and on the exterior surface. So if we think about this again, let's say that this is a plus charge here. Move that down a little bit. And this again here is the hollow sphere. I've got to have negative on the inside surface and a lot of positives on the outside. How much? Well, to get 0 electric field in here, I need to have negative Q on the inside surface but since the net charge of the hollow sphere is plus 2Q, that means in order for me to have that net charge, therefore a charge of plus 3Q will be on the outside surface. And that's good.